Yeah, so I was going through my YouTube analytics one of these days, and then I realized that YouTube was suggesting this topic idea to me. So, according to the YouTube AI algorithm, they said that most of my viewers actually have a lot of interest or this very high interest in knowing about the data analysis interview questions and the answers to these questions. So this is a video that you guys must watch because YouTube said you are going to like it. And if you don't watch this video to the end and subscribe to my YouTube channel, I will fight with you. So that aside, YouTube also gave me some suggestions to other topics that you guys might like. So let's see how it goes over time. So let's talk about the topic for today, the 10 data analytics and answers. Sorry, the 10 data analytics interview questions and answers. So on taking a look at this topic, I decided to make a research of my own. I went online and then I gathered some questions. I saw a lot of them, but I gathered some questions. Now, please note, all those questions are not mine. In as much as I've actually been in one or two data analysis interviews and they've asked something similar. I'm not going to tell you that they're going to be asking you exactly this, but they will ask you something similar. And there's also a chance that, not even a chance, it's possible that you can type this topic on YouTube and you'll see a lot of videos out there. So the reason why I'm making this video, there are two reasons. First is to look whether the YouTube algorithm is going to work. And number two is that I want to add a twist to my own. Like I want to provide an answer in my own way in the context of how I teach on this channel. So without further ado and wasting much of our time, let's get to the questions. So where are those questions? I have them here. Okay, so let's start it properly. So the first question here says that what are the steps involved in data analytics? Okay, so it depends on who you ask. Some will say four, some will say five, some will say six. The standard is four, but if you want to like go a bit to impress whoever is asking this question, you can say six. Okay, so step one is to define the problem. Step two is to gather your data sets. Step three is to process and clean your data sets. So this is where you check for errors, check for duplicates, missing values, and all of those things. Step four is to perform the actual data analysis. So you do this based on the context of the problem that you have at hand. Maybe it is EDA you want to do, it is predictive, it is descriptive, or it is a combo of all of them. Okay, I have a video of where I've talked about the type of analysis or the statistical techniques we use in data analysis. I'll be linking that video up there. And then step five is to perform data visualization, meaning you have to like make a dashboard and all of those things. And you can stop here. But the step six rather is the communication and storytelling, where you actually present your insights and express yourself, express the things that you found out in your data set. So these are like the six steps that we come across or we are involved in when it comes to the concept of data analytics, or data analysis rather. Is it data analytics or data analysis? I don't know. Some people say they are different, but that's aside. Number two is I mentioned the difference between data mining and data profiling. So I'm not going to be listing just all the differences right now. I'm going to be defining two of them in detail, and then you can just pinpoint out the differences yourself because we don't have much time. So when we mine something in real life, like the word mine means you're trying to go through a rigorous step just to get something beautiful from a crude process. So in data mining, it's a process in which it's a step in which you used to look into your data set. Okay, like you used to scan through your data set in order for you to get new information, new patterns, new insights, new relationship regarding your data set. Is that making sense to you? And now to do these things, the steps that you use for data mining in data analysis include statistical modeling, machine learning, and some AI techniques too. So we can do stuff like anomaly detection, which is a machine learning process. We can do stuff like clustering. We can do stuff like classification. We can, do outlier detection. All of these are steps that we take to actually extract new valuable insights, relationship, and information from our data sets. So that is data mining. Data profiling, on the other hand, is the act of trying to is the act of you trying to summarize and analyze your data set with a goal of trying to study is structure, is quality, and it's consistency. So you are trying to analyze your data sets with the aim of you to understand the data the more. When you profile something, it means that you're trying to like understand that thing. If you like profile me, it means that like you want to know a lot about me. You are interested in the things like that I do or the things I know. So data profiling is more about understanding the data, while data mining is more about getting new insights, getting new information about the data. As simple as that. So those are like the detailed information right there, so you can just pick out the differences yourself. So the next question is define the term data wrangling in data analytics. Now, when you wrangle something in real life, like you just say, okay, I'm wrangling this thing, it simply means that you're trying to like change it, twist it, turn it, just to make it get into something else. So, in simple terms, data wrangling is a step in analysis where we change an unusable data, something that is in quotes bad, dirty, raw. You change it from that face of it being dirty into something that is usable, that you can use to perform analysis, and you can use to plot dashboard, make dashboard, and extract insight. Is that making sense to you? Is this mic still on? Okay, yeah, sure, that's good. Yeah, so that is just a data wrangling. And under data wrangling, we perform stuffs like data cleaning and processing. We also perform data transformation. We do data encoding. We do data labeling. These are some of the few steps that allows us to take an unusable data and turn it into something that can be usable to make conclusion and solve real life problems. So step 4 is that what are the common problems that the data analyst encounter during data analysis? Now this is a very subjective question, okay, because there are several angles we can use to answer this question. Now we have 6 steps that defines data analysis, okay, like I mentioned in the first question. And all of these 6 steps, they are problems that you meet at each level, okay. So but the most popular one, the common ones that data analysts meet, is data quality problem. You see, whenever you are trying to gather data, the quality of your data is going to like be a huge problem, because once you miss it from the data quality section, all of the insights that you're going to be getting is going to be like quite not making sense. So data quality, data sourcing, yes, getting access to data is a very huge problem, because most people are all about data ethics and data privacy. So nobody wants to release their data to you. So if you spot a problem, but where you're going to get that data, you can't have access to it, or you want to scrape a Twitter page, or like, hey, like, and you can't have access to it. So that has a problem. So data quality, data sourcing, data processing, exactly. Like, so when you try to clean, remove errors, remove duplicates, in fact, data analysts spend 65% of their time cleaning data. That's to show you that dirty data is a big problem in the world of data analysis. So yeah, data processing, data sourcing, data quality, these are common problems that we face as data analysts. Yeah. So step 4 is that sorry, question 5 is that which are the technical tools that you have used for analysis and presentation purposes? So if you are an actual data analyst, whether you're a beginner or a pro in the game, there are some tools that there is no way you wouldn't have actually lay your hands on them. Number one is Microsoft Excel. This obviously is a general purpose tool that can literally do a lot of things. You understand? It was invented in the 1960s, and it has been a spreadsheet tool that's one of the best out there, and it's still the best out there. Then we have SQL, which is a programming language tool. Yeah, some people don't see it as that, but that's a problem. A programming language tool that is used to query a relational database, as simple as that. We also have statistical analysis tools such as SPSS. We have R, we have Minitab, we have Stata. All these tools can actually be used to perform statistical analysis. We also have Python. Yeah, you can use Python also to perform data analysis. We also have Tableau or Power BI. Now these two tools are quite similar to each other, because they are not only data visualization tools, but they are also good for data modeling and business intelligence analysis. So these are like the technical tools that you use for a proper data analysis. And for your presentation, obviously it has to be PowerPoint. Like it's like a general thing that everybody just uses. It goes a long way. So number six is that what are the best methods for data cleaning? Now there are a lot of steps that you have to take to clean your data set, and these steps are actually subjective. Like I used to say, the way you clean a data right now is not the way you will clean another data in the next few months or the next few days. It's actually subjective. Some data can be very, very dirty, and and you can spend a lot of time, a lot of technique and process on them. Some data are just minimally dirty, stuff like that. But the best practices that you should actually do is to always check for duplicates, very, very important. You check for missing value, very, very important. You check for spelling errors, very, very important. If you are working with more of quantitative variables, you check for outliers. Okay, outliers can actually affect the quality of your work, so that's something you have to look out for. So these are like the best methods for data cleaning. I won't say the word best, but they're like the most common methods that we use. So the next one is, what is the significance of exploratory data analysis? So basically, EDA for short is a step that we use in data analytics to explore and look into relationship within our data set. You see, when we have a lot of variables that make up our data sets, these variables can actually interact with each other. And when variables interact with each other, they actually show us patterns, and these patterns leads to insight. Also, by studying the distribution of the variables, we can actually see what is going on within the numbers that make up these variables. So that is why in EDA we are always about distribution, how your variable is being shaped up, how these two guys are interacting, so what is happening here and what is happening. It's not all about summarizing. In EDA, we are not summarizing. It is on descriptive that we summarize, but in EDA, we are trying to see patterns. We are trying to see how these two variables they interact with each other. It's more of interaction. It's more of profiling. Yeah, exactly. That's another way to see EDA. Now, the next question, which is question 8, says that explain descriptive, predictive, and prescriptive. So, I actually have a video on this, by the way. I'll still link that out. So, descriptive analysis is a type of analysis technique that is used to describe the data set. And under this, we have the measure of central tendency, aka the mean median mode, and we have the measure of dispersion, aka the range, the variance, the standard deviation, and all of those things. And we also have the visual measure here, which includes the usage of bar charts, the pie charts, the histogram. So we use numbers and pictures to actually describe and summarize our data set under descriptive analysis. Now under predictive, it's more or less like saying we want to predict one of the values in the we want to predict one variable from the order or from others. So under this case, we are going to be building regression models. I actually have a video. I think I have a playlist on regression models entirely. You can also check that out, and it's something quite interesting that you need to know. Then prescriptive, it's more or less like saying you want to prescribe a solution. So prescriptive is like a cumulative effort of everything that you've done so far. It helps you to bring every insight that you've gotten from descriptive, from EDA. It brings them together to have a concrete solution. So yeah, that's prescriptive, that is descriptive, and that is predictive. So number 9 is that what are the different types of sampling techniques used by data analysts? And this is, in fact, this question, the answer to it is part of my, sorry, I'm sort of like confused. So the answer to this question, I actually made a video on it, like I think 2 3 weeks ago, under sampling techniques and statistics, and all of those things. So we basically have two types of sampling techniques when it comes to data analysis and statistics. We have the probabilistic sampling techniques, and we have the non-probabilistic sampling techniques. They don't bring light, I beg. I'm in Nigeria. Mona, no vex for me. All right, so we have the probabilistic sampling techniques and we have the non-probabilistic sampling techniques. Okay, so examples of the probabilistic sampling techniques includes the simple random sampling, we have the cluster sampling, we have the stratified sampling, we have the mixed sampling, we have the cluster sampling too, and we have the systematic sampling. I think I repeated cluster twice now. And under the under the non-probabilistic, we have the convenience, we have the judgmental, we have the quota, we have the purposive. Now, if you want in-depth analysis or in-depth explanation of each of those each of those techniques, I'll be linking the video right here. You can check that out. So that's question number 9. And number 10 is that describe univariate, bivariate, and multivariate analysis. So basically, this is self-explanatory. Univariate means uni means one, so that means variate means variable. So univariate means when you just analyze just a single variable. So for example, I get into a class and I just take the and I'm taking the age of the student. Age right here is just one single variable, and that is univariate analysis. So under this age, I can get the mean, the median, and the mode. I can visualize its distribution using a box plot and an histogram and stuff like that. Excuse me. Now, bivariate, by means two, obviously. So that means you're actually going to be analyzing two variables at the same times, okay? At the same time, rather. So under bivariate analysis, you're going to performing stuff like correlation analysis. You know, you're trying to see the relationship between two variables at once. In fact, you can even go as far as performing inferential analysis to test for the difference between uh some category, the average of this value over two categories, all of those things. You can do that. And for multivariate analysis, in fact, under bivariate, you can also build a simple linear regression. Yeah, it's possible. Under multivariate analysis, you can in this context, we have more than two variables. So starting from 3, 4, 5, 6. So most data set that you meet in real life are multivariate. So it means that you are going to be performing multivariate analysis most of the time. So yeah, under multivariate, you can now do a lot of complex analysis. A lot of things can come into play, and the insights that you can get from a data set can be actually quite much. So yeah, that's just everything you need to know about the top 10 data analytics questions, interview questions and answers. If this video goes well, I'm going to like probably do a part two or something. But if you have a question for me, please go down to the comment section and drop those questions, and don't hesitate to like and subscribe to this YouTube channel. We'll see you in the next one, and bye for now. Thank you.